this video is going to be on solving inequalities. These are your notes for today. What we're going to do with the inequalities. First thing, review what an inequality is. Okay? Inequalities are like equations, but instead of an equal sign, you're going to use the less than, the greater than, the less than or equal to, what the bar means, or the greater than or equal to. Again, that's what the bar means down here. It means it can be also equal to. So we're going to talk about problems today that are like equations, but use those. So first thing we need to go over before we actually talk about solving them is how to graph these inequalities, because after we solve the inequalities, we're going to need to graph our answers. So we're going to go over how to do that first. So we use a number line to graph, and it's actually pretty easy. Here's my number line from negative 10 to 10. I want to graph x is greater than 3. Okay? So the first thing I'm going to do is just find 3 on the number line and circle it. Circle not the number itself below the number line, but the dash that stands for where 3 is on the number line. Circle that. Then I need to draw an arrow to show what numbers am I talking about. Am I talking about the numbers that are higher than 3 or the ones that are lower than 3? Obviously, in this case, I'm talking about the numbers that are higher than 3. So my arrow is going to point to the numbers that are higher than 3, which are the ones to the right. So I draw an arrow off to the right. And that's it. That's how you graph x is greater than 3. That's all you have to do. Okay? Now, when you have the greater than or equal to, okay? So here we go. You can write those down. Write these directions down first. You circle the number in the problem, then draw an arrow, and it's actually, you're going to find out, you draw the arrow in the same direction as the less than or greater than sign points. See here, it's a greater than, it points to the right, that's where the arrow went, because that's where the numbers that are greater than 3 are. If I had a less than sign, that points to the left. The numbers that are less than 3 are the numbers that are left of 3. So that arrow will point to the left. So the arrow that you draw is going to point the same direction as your less than or greater than sign. Okay? Nice little trick, little thing to help you remember how to do that. It makes it very easy. If it's an equal to, a less than or equal to, or a greater than or equal to, then what you do is you color the circle in. So here's an example. If I want to graph x is less than or equal to negative 5, again, just go to negative 5, circle that spot on the graph. It's less than, so I'm going to draw the arrow to the left. But since it was equal to, had the bar down below, I'm going to shade my circle in. Okay? By shading in, that tells me that 5 is included in this, because negative 5 is equal to negative 5, so that number does make this a true statement. That's what the graph is showing, the numbers that make this statement true. If I pick any number over here to the left of it, negative 6 is less than negative 5, negative 7 is less than negative 5, and negative 5 is equal to negative 5. So all of those numbers make this statement true. That's what I'm showing on the graph. So it's very easy to graph them. All you got to remember, point the arrow same direction as less than or greater than sign, and if it's got the equal to, color it in. So I want you, on your notes, draw a number line and try and, well, 2 different number lines, and graph these 2 down here. X is greater than or equal to negative 6, and x is less than 8. And then Mr. Scapoletti will look at those and make sure that you are doing them the right way. And then when everybody's ready, you probably want to pause this. Then when everybody is ready, you go on and go to the next slide. So here we go. Now that everyone knows how to graph, next slide here. Now we're actually going to talk about solving these. Okay? To solve inequalities, it's actually, you do the exact same thing as you did for equations. You're just going to do the opposite operation on both sides of the inequality. Again, I need to keep this balanced. Even though it's not an equal sign, I still need to keep this balanced. Whatever I do on one side, I'm going to do on the other. Okay? This is an addition problem, which means I need to subtract. I'm going to subtract the 7 on both sides. When I do that, on the left side, 7 minus 7 is 0. So that means I have just an x left. 15 minus 7, of course, is just 8. But I already made a mistake here, and this is a mistake a lot of people make. I wrote down the equal sign, because I was in the habit of doing that for the equations we were doing. It's not an equal sign here. And make sure you don't do this. It started out as a greater than sign. I got to keep that the same. My solution should be x is greater than 8. Okay? Not equal to 8. X is greater than 8. In other words, what I'm saying here with this answer is if I pick a number that's higher than 8 and plug it in here, my answer should be higher than 15. So to check these, I'm going to pick any number that makes this statement true, like 10. 10 is higher than 8. And I'm going to plug it in, and 10 plus 7, of course, is 17. And 17 is greater than 15, which is what this statement says. When I plug it in, I should get something that's greater than 15. So that tells me it checks out. Okay? So that's how I'm going to do my check here. It's not an exact answer. I don't want to plug in 8 and get 15. I want to plug in something that's higher than 8 and get an answer that's higher than 15. Okay? Then I do need to graph my solution. So I'm going to make a number line. Number lines don't have to be anything special. You don't have to, have a perfect number line here. I need to show 0. I just need to go out far enough that I can see the number I'm graphing. I don't have to label. I'm just labeling every other one here. Put a couple negatives in. I don't need a ton because I'm over a positive 8. Circle your answer. It was 8. It's greater than. So the arrow needs to point to the right. I did not have the equals to, so I do not color it in. That's the graph right there. So I solve it just like the equation. Opposite operation on both sides. Make sure you're not putting in equals. Make sure you're keeping the inequality symbol in there. To check it, I pick any number that makes this true. A number that's bigger than 8. Make sure when I plug it in, I get an answer that's bigger than 15, which I did. And then I graph it just like we did the other graphs. Okay. And once everybody's done copying this, we'll go to the next slide. Here's the next one. X minus 18 is less than or equal to 11. Okay? Again, this is one step. It's got subtraction. So I'm going to add 18 on both sides. On the left side, negative 18 plus 18 is 0. So that leaves me with just an x. On the right side, 11 plus 18 is 29. It was a less than or equal to, so this is less than or equal to 29. So now I got to do my check. So I can pick any number that's less than or equal to 29. Make a nice easy one. How about 25? Put it in the original equation, x 25 minus 18, and I know that gives me 7. What I want to check is that answer less than or equal to 11? And of course, 7 is less than or equal to 11, so that checks out. Now, I need to graph. So I'm going to make my number line. Now, I got to graph x is less than or equal to 29. So, I'm obviously not going to count by ones here. I would just count by fives. Okay? So I'm counting by fives. I label every other line. Now, obviously, 29 is not going to be exactly on here. So all I have to do, I want 29. I'm just going to go right next to 30. Put my circle. It's a less than. Points to the left, so my arrow is going to point to the left. It does have the equals, so I'm going to color this in. And that's my graph of my solution. That's it. Opposite operation, get my answer, pick a number that makes the answer true, make sure to plug it back in, make sure it makes the original sentence true, then graph, and make sure you're graphing the right thing. I need to graph my answer here, x is less than or equal to 29. Okay, when everybody's done, you can go to the next one. Here is the one difference between inequalities and equations. Make sure you have this written down. When you multiply or divide both sides of an inequality by a negative, the inequality symbol switches around. So here's what I mean. Okay? This is multiplication. So I'm going to divide both sides by negative 4. Negative 4 over negative 4 is 1, so I have just an x here. 48 divided by negative 4 gives me a negative 12. Because what I divided by on each side here was negative, this symbol switches from greater than to less than. Okay? So my solution is x is less than negative 12. So let's check and make sure that this is right. I need a number that's smaller than negative 12. That's like negative 13. That's smaller than negative 12. I gotta go further down to the negatives. If I plug that in to the original equation, negative 4x, negative 13 times negative 4. Two positives, two negatives give me a positive. 4 times 13 is 52. So now I'm going to check. I wanted my answer to be greater than 48. Is 52 greater than 48? Absolutely. So that means it checks. Now I need to graph my solution. So I make my number line. Now I'm going down to negative 12. I'll probably just count by 2's. So here's my number line. So I'm going to circle negative 12. It's a less than, points to the left, so arrow goes to the left. Do not have an equals to, so I do not color it in. That's my graph right there. So opposite operation, same as before, only difference, because this was a negative, this sign switched from greater than to less than. So there's my solution. I pick a number that's smaller than 12. You got to be very careful with these ones. Smaller than 12 is going to be a number that's further down in the negative. A lot of people want to put like negative 11, negative 10 in here. So be careful you're picking the right number. Plug it in, make sure it works, graph it. And everybody's got it good with this one. Go on to the next slide. Here's the next one. This one's got division, so that means I need to multiply. Multiply both sides by the negative 3. So those cancel out, and I have just a y. And on the right, two negatives give me a positive 24. Now, what you have to ask yourself is, would I multiply each side by a negative? In this case, yes, it is. So that means I switch this around from less than to greater than, and I keep the equal to. Okay? So, again, I got to check this. So I need a number that's bigger than 24. But I don't want to pick just any number. Okay? I want to think about this. With the number I put in, I'm going to be dividing it by -3. So I might as well pick a number that's divisible by 3. So if I want something bigger than 24 that's divisible by 3, how about 30? Plug that in. 30 divided by -3 is -10. So now I got to check. Is that answer less than or equal to -8? And yes, it is. Remember, less than -8 is further down in the negative. So yes, that is true. Okay? And again, you got to graph it. Make your number line. Make sure you always put the arrows on the end. Mark down your 0. I'll count by 2's again. I'm just labeling every other one just to go quicker. Okay? At a circle 24, it's greater than, points to the right, arrow to the right, has the equals to underneath, so I'm going to color it in. And there's my graph. So I did the opposite. It was a negative because I was multiplying on both sides, so that did switch it around. I wanted to pick a number that 3 would go into since I'm going to be dividing it. Then I checked that it works and graph it. Everybody set with this? You can go on to the next one. Last example. This is a real important one because this is one that messes up a lot of people. This is a multiplication, so I'm going to divide. I divide both sides by the 7. So on the left, 7 over 7 is 1, so I just have x. On the right, it's negative divided by a positive is a negative 7. Now the question is, do I flip this around? A lot of people think yes, because they see a negative here, they see a negative answer, yeah, flip it around. Actually, we do not flip it around. You only flip it around if what you divided by, in this case the 7, were negative. Since it is not, that sign does not flip around. It's x is less than -7. So, going to put in a number that's less than -7, like -8. Plug it back in. -8 times 7 is -56. Now I got to check, is that less than -49? Yes, it's further in the negative, so it is smaller. It does check. Got to make my graph. Here's my number line. I'm just going to -7 so I can count by ones. Okay, so there's my number line. Circle -7. Less than means it points to the left. There's not an equal to, so I don't color it in. That's my graph. Once everyone has this, you're done with this, and you can do some example problems from the homework.